Hello. Let's go through another example of how to solve a differential equation, and one that deals with exponential models. So what we have here is a radioactive substance, such as thorium-23, decays at a rate. Okay, here we go. Decays at a rate. So here is a decay model. All right, so decays at a rate. So we're going to say this is d thorium, and let's call this something. I'll call this DH, okay, for thorium. I don't want to use T because it's going to be a little confusing because we're going to have T on the bottom there. So DH dt, all right, that's our decay rate, which is, all right, oh, I forgot to put the is proportional, so is proportional to the amount of substance present. So, all right, because it's proportional, we're going to have this constant proportionality, so we're going to add our K in value. So whenever you see K, need to add, all right, K value, all right, K value, all right, which is our constant of proportionality. So we're going to K of the amount of substance present. So what is that substance present? Well, that's going to be H. That's the substance. All right. Now, if you watched my previous videos, we know that this differential equation actually is an example of an exponential model, exponential decay model. And the exponential decay model is written like this, where we have, this would be h of t equals h sub 0, because that's our initial condition, e to the kt power. Just to verify that how this all works, all right, we can go through and just solve this. So we have dh, all right, over h equals k dt, all right. And so going through this, if you notice this differential equation, you can go a little bit faster. But I'm just going to go here. KT plus C. Now let's find out what we have here. It takes about 24 days for the sample of thorium to decay. All right, so we're going to have that. So when T equals 24, all right, T equals 24 days, we're decay to a point where it's half. Okay, so whatever the half of the initial amount is. All right, so H is going to be half of whatever that initial amount is. I'm going to call this initial amount H of 0. H of 0 is the initial amount. Okay, H of 0 to be half of that. All right, so that's our first point. The next thing, let's keep on going through. It says, how long to the nearest day will it take for a sample of 10 grams? So I guess, all right, when T equals 0, we'll have H of 0, which is going to be 10 grams. Okay, of thorium to decay to 1 gram. All right, so how long will it take? So we're looking for that T when H equals 1 gram. All right, so with that, we know that at 25 days, put that in there, it should be 5 grams. All right, so we have this. So from here, I'm going to take my initial condition. All right, that's going to help me find C. So I plug that in there. We have natural log of 10. All right, that's going to equal C. We can go through and just solve this. All right, so we have natural log of H just to verify once again that we have that model. If you do this enough, you realize that, okay, I can probably just, if I identify this differential equation, I can just write this model out because it's pretty fast and efficient. All right, we have this. I'm going to have H. We know that this goes in front, so it's going to be e to the kt, all right, times e to the natural log of 10. We know using the properties of exponents and logs, these cancel out, so we have 10 e to the kt power equals h. All right, we're going to use this half-life, all right, right here of 24 to solve for K. So we're going to use this to solve for K. So use this to solve for C. Use initial to solve for C. And we're going to use this one to solve for K. All right, solve for K. Okay, so right here, I'll plug in my values. So what we got right there is going to be 5 grams. That equals 10 e to the, all right, we said 24K value. So we have 1/2. All right, 1/2 equals e to the 24K. And then we'll natural log both sides. So natural log of 1/2, all right, divided by 24, that's going to equal K. All right. And so this actually comes to our one point that you might have found in pre-calculus, is that whenever you have your natural log of whatever the half-life is divided by the time, you can get your K value pretty easily. And in going through and doing that. All right, let's take out our calculators. Let's find out what this value is going to be. All right, so if you take a calculator, punch that in there real quick like a fox. All right, divided by 24, and I'm going to run the 4 displays, and we realize it's negative. And that makes sense because it is decaying. And so our growth rate, actually isn't growth rate, it's our decay rate, is going to be negative 0.0289. All right, we're going to take that. We're going to plug it back in here. And so we'll have h of t equals 10 e to the negative 0.0289 t power. From here, my friends, we want to figure out our problem. So we're going to take h and plug it in there. We have 1 equals 10 e to the negative 0.0289t. And now we're just doing some pre-calculus advanced algebra things. So we're going to go natural log 10. We're going to have this equals e. I'm just going to show all the work. You probably can maybe skip past this part if you just want to see the end. Or maybe you're just going to turn it off. I don't know. All right, so 0.0289t. And so finally, we have the natural log of 10, or so 1/10. All right, divided by negative 0.0289. All right, and that's going to be our t value. And we have natural log of 1/10 over negative 0.0289, which is approximately, give us about 79.674. All right, I believe that's days. And that's what we have there. All right, I'm going to just make sure we have answered the questions in this problem correctly. All right, how long to the nearest day? Oh, round to the nearest day. Because of this day, it's probably going to take, since we won't get it at 79, so I'm going to just take this and say it's going to be 80. All right, 80 days. And that's what we have as our nearest answer. Okay, so that's going to be our approximation for that right there. Okay, so once again, going through and we're solving this, all right, using exponential model, we realize that when we have decay rate is proportional to amount of substance, this makes this. I've solved it again. Use your points that you're given the problem to solve for your initial condition and also your K value constant proportionality. All right, there we go. I hope this helps you out. Good luck and God bless the rest of the problems.